Hi everyone and welcome to this video. In this video we are going to be doing more graph translations. Okay, so in the previous video we did some graph translations. We did how to translate the graph in terms of shifting left and right and up and down. In this video we're going to do the following. We're going to say by manipulating the algebraic expression of a function, we can reflect the graph in the y-axis or the x-axis. Okay, so again in the previous video we did shifting the graph left and right and also up and down. In this video we're going to be looking at reflecting the graph about the y-axis or x-axis, as if the y-axis or x-axis is some kind of mirror. Okay, so I'll show you what I mean. Start with the function, let's just call it f of x as is standard, and then we're going to say let g of x equal negative f of x. Okay, so what happens in this case? In this case we have that the graph of g of x is the graph of f of x reflected about the x-axis. Okay, so what does it mean? It means basically if we have a point, say AB in f of x, on the graph of f of x, that point is a minus b in the graph of g of x. So as you can see here, the x coordinate stays the same, but for each x coordinate we have that the y coordinate, which is of course the f of x value, is now of course negative in g of x. So we just take the negative of that. So the consequence of this is that we have a reflection. The consequence of this is that we have a reflection in the about the x-axis. So let's do an example. Okay, and let's say we have f of x is equal to x plus 4. Okay, so I'm going to draw that graph. That's a straight line graph. It looks something like this. At this point here, we're going to have the point 0, 4, okay, which is of course the y-intercept, and at this point here, the x-intercept will be minus 4, 0. Okay, I'm actually going to draw that over here, minus 4, 0. Okay, so what is g of x? So g of x will be minus f of x, which is the same as minus x plus 4, which is minus x minus 4. Okay, so what we're going to do first, we're going to take each point on this line, right on that line, and then we're going to reflect it in this way over here. Okay, so we look at this point, so we've got 0, 4, so that means the point 0 minus 4 is then on the graph of g of x. Okay, we can take another point here. The point, there's a point in this graph which is the point minus 2 and 2. So that means that the point minus 2 minus 2, just taking the negative of the y, is going to be on the graph. We can take this point over here. So that point over there would be minus 6 minus 2, and you can check that. It's very easy to check. So again, if we're looking for the corresponding point in g of x, we're just going to take the y coordinate and change the sign. So that means we're going to have the point 6, minus 6 and positive 2, so minus 2. And you can see what's happening here. What we have is a straight line that looks like this, and that would be g of x. Okay, and you can of course see algebraically this green line is of course the same as the line minus x minus 4. So what we've done here is we've just reflected each point in the axis, which sort of acts like a mirror. Okay, so for example, we looked at this point here, right, and we look at this distance, right, the y value distance, and we reflect it to the other side, and we get that point there. And we've done that for each point. Okay, and as you can see, what we have is a clear reflection about the x-axis. Okay, so that's what happens when we let g of x equal something like this. Okay, let's do another example. Let's say we've got f of x is equal to the parabola x minus 4 squared, which is going to look like this. We're going to have minus 4 over there, or sorry, x is 4 will be a root. Sorry, that's over there. And then it's going to look like this. Okay, this point here, if we multiply this out, we're going to get x squared minus 8x plus 16. So this point here is going to be 0, 16. This point here is going to be 4, 0. Okay, so if we want g of x, okay, g of x is going to equal minus f of x. Okay, then that's going to be minus x minus 4 squared, which is going to be minus x squared plus 8 of x minus 16. Okay, then we've got the negative a coefficient for the x squared term, so we know it's going to be down like a frowning parabola. So what's going to happen? We know it's going to be this sort of shape, right? And we know that this is the roots, right? This point is going to be reflected over here, and we've got 0 minus 16, right? This point is going to stay there, and that's what we have, a simple reflection in the x-axis. Okay, so whenever you see something like this, then you know the graph is just going to be reflected about the x-axis. We can also reflect in the y-axis. Okay, so now let g of x equal f of minus x. Okay, and then what happens? And then the graph of g of x is the graph of f of x, this time reflected about the y-axis. Okay, so basically what's going to happen, if we have a point A and B in f of x, the graph of f of x, it's going to become minus a b in g of x. Okay, so it's the whatever value in f which gives you that particular y value, you're going to take a negative to get that same y value, the same y output. So the input of a gives you a y output in f of b, and the input of minus a then must give you the same y output b in g of x. Okay, so what does that look like? Okay, so I've got y and x, and let's take the same graph. Let's take f of x x plus 4. So it looks like this. Okay, we've got the points there. That is 0, 4 and minus 4, 0. Okay, so what we're going to do is we're just going to take each of these points and reflect it about the y-axis. So this point here is going to become this point. So minus 4, which is 4. The y-coordinate stays the same. That point stays over there. This point over here. So this would be, let's say, minus 6, and minus 2 is going to become positive 6 somewhere over here. And of course stays minus 2. And then we have this line over here. Okay, and that is g of x. So g of x would be f of minus x, which is going to be minus x plus 4. And this green line over here, okay, is of course minus x plus 4. We can see the y-intercept is 4, so that's correct. And the root would be 4, so that's also correct. Okay, and that's all it is. So when you see a situation like this, we are reflecting about the y-axis. Okay, let's do one more example. Let's do a parabola. Okay, let's do the same example. F of x is equal to x minus 4 squared, right? So g of x is going to equal minus f of x. That's going to be minus x minus 4 squared. Okay, so let's draw f first. So we've got y and x. F is going to be, the root is x is equal to 4. And of course it's going to look like this, as we've just seen not so long ago. And this point here is going to be 0, 16, and this point here is going to be 4, 0. Okay, so now if we are reflecting, if we want g of x is equal to f of minus x, we're going to reflect about the y-axis, right? So this point here, it's going to reflect to this point, which is minus 4 and 0, right? This point here is going to stay on that point, so we're going to get something like this, roughly speaking. Okay, and it really is that simple, guys. Of course we can just double check the algebra on this. So if we multiply this out, we're going to get x squared, and then we're going to get plus 4x and plus 4x, or plus 8x, and then minus 4 plus 16. And that you can see is indeed this green graph that we have over here. Got the correct y-intercept and of course the roots. Okay, so that's all it is. That is how we reflect the graphs in the x-axis and y-axis. Just to quickly recap, if we have a graph f of x, and then we take g of x and let it equal f of minus x, then we reflect about the y-axis. Okay, and of course if we let g of x equal to minus the entire value of f for each point, then what we do is the graph of g of x is the graph of f reflected about the x-axis. Okay, and that's all there is to it. It's really easy to remember, so give it a go. Otherwise that does bring me to the end of this video.